So the two name reaction I'll be talking, these are called Clemmensen Reduction reaction, and the next one is called Wolff-Kishner Reduction reaction. I hope I'm taking their names in a proper way. So these two reaction is actually about the reduction of aldehyde and ketones. So what that mean, when you let the aldehyde and ketones undergo reduction, you need to understand. So let's start there and see what this is. So the first one, I want you to understand that this is, the topic I have is called reduction of aldehyde and ketones. And like I said, it had so many reactions, but the two I'm concerned. The first one is called Clemmensen Reduction reaction. Clemmensen Reduction reaction. So what this reaction is, let's do that. A carbonyl group, when react with a carbonyl group, when react with zinc amalgam, you probably know what amalgam is. I tell you what, in case you do not know, this is a very important term. This started with your early childhood and now it's coming out almost every year. Amalgam is nothing but an alloy where one of the component is mercury, right? So one of the component here is zinc and other is your mercury, and this reaction is carried out in presence of concentrated hydrochloric acid. Now let's concentrate on the reaction and try to get it. In HCl, it result homolysis. So what you will form, if there are two HCl, you will form two free radical of hydrogen and you will form two free radical of chlorine. Similarly, these two bonds undergo cleavage. So this will result, two free radicals. So what I will do, I will place these two hydrogen, removing the oxygen. So now this become C, and one of the place is occupied by H, other is also occupied by H. So this is what. Now this is the CH2 I am talking, because there it can be like anything. It can be carbon, it can be a functional group or anything. So this is how you have converted, aldehyde or ketones to CH2 group. And then the question is, what else it's going to be? The byproduct here is going to be water. Why? For doing so, this is really very important that you don't need only, 2 HCl, you need more amount of HCl also. So this is what the Clemmensen reduction is about. Now, I hope you have understand. Let me write the statement part here. When aldehyde or ketones undergo reduction in presence of zinc amalgam and concentrated hydrochloric acid, it converts into CH2 group by releasing water. Right? So this is your Clemmensen reduction reaction. I hope I have helped you, and this way it's going to be really easy. Now I have to take the next one. which is the Wolff-Kishner reduction reaction. So the next one is Wolff-Kishner reduction reaction. Now, what happened during this reaction? An aldehyde and ketones react with, hydrogen. It react with hydrogen and in presence of KOH, and then it converts into CH2 again, right? So this is what the fact about the, reaction is. So let me write this first and then I will make a reaction. When an aldehyde or ketone undergo reduction in presence of hydrogen and KOH, it converts into CH2. It converts into CH2 and release nitrogen gas. Right? So this is the statement part. Now let's come up with the equation. We have an aldehyde or ketone which react with hydrogen. This is the hydrogen, and this reaction also require KOH, but this doesn't have a huge role, right? What I will do, I will break both of these bonds, in a homolytic fashion, right? So what will happen, these two bonds will undergo the same way cleavage. Now what will happen then? Both of these hydrogen will come with the oxygen to produce water. So one of the byproduct is water, right? And then this one, this one will convert into NH2, right? So this is what the intermediate product is. In the next step, what happened? Both of these bonds again undergo cleavage. And these two hydrogens also undergo cleavage. So this one come out as a nitrogen. And these two hydrogen occupy the carbon. So again, this Wolff-Kishner reduction reaction produces CH2 due to the reduction of the aldehyde or ketones. I have tried my way to make you understand this, really, because if this is not something you are getting it in a very unique way, I don't think this will be helpful. You will be tired of learning and what is that called, ratification and all. So stop doing that. Practice a little bit, in case you need to understand what is the mechanism right here. Even I can explain you that, but I want to make this short. I want to make this happen very quick. So that's why I did that. I repeat back here, both of the hydrogen bond will undergo cleavage, right? So, and these two bonds are also undergoing cleavage. What will happen? The nitrogen gas, they are highly stable, as compared to any other situation they are into. So the nitrogen will come out because of their higher stability. Now, these two hydrogen will attach to the carbon and this will form a CH2 group. So this is what the Wolff-Kishner reduction reaction is. So I have to wind this right here, and I will take another very important topic in the coming section. That will be about the tolerance and failing test, which is very, very important. But this was also one of those very important name reactions you had to. I would say thanks for watching. In case you haven't done that favor, this may be the first time I'm saying you need to share with your friends if you really like my effort. And in case you hate, that's okay. But if you like, you need to share it, and you need to subscribe. You need to do whatever the whole online system required. Right? Thanks for watching.